Let's take a look at this problem. Got f of x is equal to 3 square root of x minus 1 minus 4. Says show that the given function is 1-to-1, find its inverse. Check your answers algebraically, graphically. We probably won't do the graphical part. Verify the range of f is the domain of the inverse of f and vice versa. Part of that verification is done through the graphing calculator, so we'll focus on finding the inverse. First off, let's just note our domain here. When you got a radical with an even index, you take what's inside the radical, the x minus 1, and you set it greater than or equal to 0. So then you solve it, and you get x is greater than or equal to 1. That would be our domain. Okay, so steps to find our inverse. Step 1, replace f of x with y. So we got y is equal to 3 square root of x minus 1 minus 4. Step 2, swap your x's and y's. Interchange them. Where the y is, you put an x, and where the x is, you put a y. Step 3, solve for y. Well, I want to get the square root by itself, so I take negative 4 to the left side, becomes a positive 4. Then divide both sides by 3. So we get x plus 4 over 3 is equal to square root of y minus 1. Now I want to get rid of the radicals, so I'll square both sides. So I'm going to have x plus 4 over 3 squared is equal to the square root of y minus 1 squared. So that gives us x plus 4 squared over 3 squared is equal to, when you square a square root, they cancel each other away. So that gives us y minus 1. So we have x plus 4 squared over 9 equals y minus 1. And take negative 1 over. And I'm going to take this 9 and put it out in front. So I got 1/9 x plus 4 squared plus 1 is equal to y. And then step 4 is replace our y with our inverse notation. And we have this right here. Now, it doesn't hurt to understand what your range is on your original function, because that helps you figure out what your domain is down here. Okay, if I go back to my original function, the negative 4 here, that means I'm going down 4. This negative 1 that's inside with the x, this shifts left or right, opposite what you think. The negative 1 will make you think it's going left 1, so it's really going right 1. Now this just affects the degree that it opens up or opens down, depending upon the problem. So if I think of my basic graph, which is the square root of x, like this right here, if I think about shifting it right 1 and down 4, right 1, 2, 3, 4, down 4, that would be right there, ignoring the 3, which means our range would be negative 4 to positive infinity. So down here, our domain, for your function and your inverse, they swap. So domain, your range is negative 4 to infinity. So down here, your domain will be negative 4 to infinity. And how we write that is we got 1/9 x plus 4 squared plus 1, comma, and then you say x is greater than or equal to negative 4. Usually they're written in conditions in that form. Now the other way you could do it is you could use a graphing calculator. I'm having a little bit of trouble with my graphing calculator on this particular computer though, but that's how you do it. How would you use the graphing calculator? Well, you look at the original graph, and then you flip it, reflect it across the line y is equal to x, and it helps you figure out what your answer should be. And let me see, I was trying to think what else they were asking. Graphically verify the range of f is a domain of, okay, yeah. And of course also the range here, I'd have to go up to my domain up here. My range would be 1 to infinity, like that.